We're going to start Chapter 4 today, and Chapter 4 starts with the Triangle Sum Theorem. And that's a pretty easy theorem. All it says is the angles on the inside of a triangle will always add up to 180 degrees. So you'll see in the first sentence here, what it says is the sum of the angle measures of a triangle is 180 degrees. And so for that picture, measure of angle measure of angle A plus measure of angle B plus measure of angle C would be 180 degrees. So it doesn't matter what your triangle looks like, the angles on the inside will always add up to 180 degrees. So let's look at a couple example problems. So in example 1A, obviously you see a triangle. One of the angles is 40 degrees, one of them is 85 degrees, and they're asking you to find out what's the missing angle. And so you could either make that question mark an X if you like dealing with algebra, or you could have just taken those two numbers, the 40 and the 85, and subtracted from 180. So I think most of you guys like to do the subtraction instead, so let's do that. So that question mark that's missing, that angle that is missing that they put a question mark on, would be 180 degrees minus 40 minus 85. Because if the whole triangle has to add up to 180, we could just subtract the other two angles to get the missing angle. So if you did that subtraction, you would get the missing angle is 55 degrees. Now in example 1b, you really can't subtract from 180 because they put an algebraic expression there. So that 5x plus 6 is going to prevent us from simply subtracting from 180. So this time we are going to use algebra instead. And we're just going to take the three angle measurements that we see. The 5x plus 6 is one of the angle measurements, plus the 82 is the second angle measurement, plus 52, which is the third angle measurement. Again, all three angles in a triangle are always going to add to 180 degrees. If we combine our like terms, we're going to have our 5x, but all of our like terms are our numbers. We're going to add them up and get 140. Equals 180 degrees. And then, of course, hopefully now it's a simple algebra problem for everybody. If you subtract 140 from both sides, you'll get 5x equals 40. If you divide by 5, your x will equal 8. All right, pretty simple. And then in the next one, example 1c, don't forget that you have to do all three angles in the triangle. So that little box in the corner we know to be 90 degrees, right? We have to remember that that is 90 degrees. So it should be included when you add up the three angles. So we would have, whoops, sorry about that. We would have our 6x minus 8 plus our 6x plus 2. Plus our 90 degrees. Again, we have to always add up all three angles in the triangle, and they'll add to 180. Again, if you combine your like terms, you'll get 12x minus 6. Oops, sorry, not minus 6. My bad. 12x, and then we'll have a minus 6 plus a 90. So that's going to give us plus 84 equals 180. If we subtract 84 from both sides, we're going to get 12x equals 96. If you divide by 12, our x will equal 8. Looks like I like 8, so we got 8 in both the example 1b and 1c. All right. So again, all three angles in a triangle always add to 180 degrees. Now there was a shortcut, I guess it's kind of a shortcut that we could have done in example 1c. Anytime you have a 90 degree angle, so anytime you have that box in the corner like we did on example C, we could say that the other two angles have to add to 90. So a shortcut would be to take the other two angles and add them to 90. Because think about it, if the whole triangle has to add to 180, and one of your angles is exactly 90, that means the other two have to add up to 90. So we could have said 6x minus 8 plus 6x plus 2 equals 90. So if you have a right triangle and you notice that, you could do this shortcut, although some people don't think it's that much of a shortcut, but it kind of is. You'll get 12x minus 6 equals 90. You'll add 6 to both sides. You'll get 12x equals 96. and your x will equal 8. Same exact answer. So we could do this method or we could do this method. Either one is fine. You'll still get the same answer. So some people just like to add everything up to 180 in a triangle. They don't want to bother with that shortcut. So it's up to you. All right, if we move on to example 2, you're going to notice that there's an angle that is labeled outside of that triangle. And so up above, when I read the theorem to you, I said the sum of the inside angles in the triangle add to 180. So even though that's not what it said in words, that's what I said to you. The sum of the interior, the inside angles in a triangle will add to 180. So in example 2, that 142 degrees is not inside the triangle. And so the problem is we have two unknowns, right? So that 142 degrees is actually called an exterior angle instead of an interior angle. And what you should notice is that you could figure out this missing angle inside the triangle because 142 and that missing angle make a linear pair. So if you just focused on these purple lines that I'm drawing right here, that's a linear pair happening. And so you can use your linear pair to figure out that the missing angle inside of the triangle is 180 minus 142. Because remember, linear pairs also make 180 degrees. 180 degrees is kind of a big deal in geometry. It happens a couple of times. All right, so that missing angle there is actually 38 degrees. And we used our linear pair to figure out one of our missing angles inside of our triangle. And now that we know now we know two. Now that we know one more, we know two angles inside our triangle. And so the missing angle that's labeled with a question mark, we could just subtract from 180. We could take 180 minus that 40 minus that 38, and we would get 102 degrees. Again, all three angles in the triangle have to add up to 180 degrees. And so you have to just do whatever you need to get the inside angles to add to 180. And in this case, we had to use our linear pair. Same thing in example 2b. We need to figure out what this missing inside angle is because, again, you can't have more than one unknown variable in a problem. You cannot put an x here. Anytime there's an x in the problem already, you cannot use the same variable. So you're not allowed to put an x there. And if you put a y there, that wouldn't be very helpful because now you have two variables. So the only thing that would be helpful is if we could figure out exactly what number to put there. And we can, because again, we have a linear pair happening. So we would take 180 minus the 130, and that would give us 50 degrees right here. So if we use the linear pair that's happening, and that's what's really happening there is we have an exterior angle of 130, and then we have an interior angle of 50. So inside our triangle, we call those our interior angles. And outside our triangle, we call that an exterior angle because it's coming right off the one side of the triangle. All right, now we could add up the inside to 180 again. If you know something about all three measures of the inside angles, you could add them up and set it equal to 180. So we're taking the 5x, the 8x, and the 50, right? The 5x, the 8x, and the 50, and adding them up to 180. So we get 13x plus 50 equals 180. If we subtract 50 from both sides, we'll get 13x equals 130. And if we divide by 13, our x is equal to 10. So it kind of took two steps to figure out what one of the missing angles on the inside of the triangle was. Again, we used that linear pair that we're seeing in that picture. And then we used the fact that the inside of a triangle also adds to 180. So linear pairs add to 180, inside of the triangle adds to 180. Like I said, 180 is kind of a big deal in geometry. All right, in example 3 and 4, I've given you some word problems. And so example 3 uses the word ratio. Anytime you have a ratio, it doesn't mean the angles are going to be exactly what's in that ratio. It means they're going to be some multiple of 2, 3, and 5. So if we draw a picture of a triangle, And think about that ratio of 2 to 3 to 5. If you put a 2, a 3, and a 5 in here, that would make 0 sense, right? 2 plus 3 plus 5 does not add up to 180 degrees. So anytime you have a ratio like that, it says some multiple of 2, 3, and 5 adds up to 180. So we're going to put x's next to all of those. All right? So if you put an x next to all those and then add it up, you get 2x plus 3x plus 5x equals 180. If you add those numbers up, you get 10x equals 180. And if you divide by 10, your x equals 18. Now, none of the angles actually equal 18. They're a multiple of 18. So one of the angles, and I'm just going to call it angle 1, 2, and 3. It doesn't really matter which one's 1, which one's 2, and which one's 3. But I'm going to call it measure of angle 1, measure of angle 2, measure of angle 3. All right, so the first one I'm going to look at is the one that has the 2. So we have 2 times x, or 2 times 18, which equals 36 degrees. The next one has a 3 times the x, so 3 times 18 is going to equal 54 degrees. And then the last one is 5 times our x, 5 times 18, which equals 90 degrees. And if you added up a 36, a 54, and a 90, you would get 180 degrees, which would make sense because all the angles in our triangle are supposed to add to 180. All right? So anytime you see a ratio problem, you take that ratio and put x's next to all the numbers, and that will help you figure out, well, in this case it's triangle, but we could have done that with other things. We could have done that with like complementary angles, supplementary angles. All right, example 4 says we have triangle PQR. And just like I did in example 3, I'm a visual person and I want to see the triangle. If I don't ask you to draw the triangle in a problem, then you don't have to. But for me, it kind of helps me solve the problem. So it says triangle PQR, angle P is congruent to angle R, and the measure of angle Q is twice the measure of angle R. And so you are going to want to introduce some variables here. Since they said P was congruent to R, that means they can have the same variable. So I'm going to give them both an X. And then it says the measure of Q is twice the measure of R. So Q is going to be 2x because we called R x. So then Q must be double that, or 2x. Now that we have all 3 angles in our triangle labeled, we can add them up to 180. So we have 2x plus another x plus an x, right? That's exactly what I see labeled for my triangle. If you add those up, you get 4x equals 180. If you divide by 4, your x is equal to 45. So, doesn't really matter. Well, this time it does. Actually, we're going to have measure of angle P. We're going to have the measure of angle Q. And we're going to have the measure of angle R. So, PQR. So, P has an x by it, so it is 45 degrees, exactly 45. Q is 2 times x, so 2 times 45, so that equals 90 degrees. And then we have R is just x, right? R has an x by it, so it is 45 degrees. So our angle measurements are 45, 90, and then another 45. And again, if you add all of those up, they do add up to 180 degrees. All right, so if we go back to the top of the notes, the only thing we really have learned is that the inside angles in a triangle always add to 180 degrees, but you can see that the problem could look quite different each time, but we're going to use that same fact.